Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard. Yes, we are looking at this question. It says that draw magnetic field pattern of solenoid. Okay, what is a solenoid? It is a coil of many loops. Okay, so let us see how the loop looks like. Okay, let's assume that one is 1. That's the second loop. So this is how a solenoid looks like. Okay, can stop there. So if that's the case, what's the next part is to indicate direction of our current. Suppose current entered here. What does that mean? That in this side is coming down like that. The side which is close to you, it is turning down. Okay, after having it, then what is next? Then next, we predicted the direction of the North Pole. Okay, when you are using the right hand rule, it changes a bit. We use the same right hand, but the fingers are pointing in the direction of current, and the thumb points in the direction of the North Pole. Okay? We say the electricity enters, it comes down like that. So the part which is facing you, electricity is going down. So what do? You put it like this. These fingers are pointing in the direction of electric current, and the thumb is pointing in the direction of north. So what does that mean? That our North Pole is this side. And if this is north, then this side is south. Okay. So what is the next? Next part is to have the electric field. Okay. How does the electric field look like? It comes like that and like this and like that and like this. Okay, here we can represent it like that. Okay, from our grade 10, we know that magnetic field always moves in one direction. It's from north to south externally. So if this is our north, so magnetic field will be moving like that. The same applies here. So it's from north to south. So what do we see? This one is coming out, and this one is entering. Now, when you look at this magnetic field, it reminds you something. What does it remind you? It reminds you of the bar magnet. This field is very similar to that produced by the bar magnet. Let us put it here. Yes. Similar to the field produced by the bar magnet. So there we are. Now suppose we change and we have our solenoid. Yes, like that. But this time around, our electricity is reversed. It comes from this side. So what does that mean? It means that this side, electricity is coming up, the side which is next to you, because it went like this and it comes up. Yes, that's what we have. So if that's true, then what do we do? We have to predict the direction of the north. You don't forget that when you're using the right hand rule on the solenoid, the fingers are pointing in the direction of current. Meanwhile, the thumb points in the direction of the north. So here we put our fingers like this because it's going up. And so we know our north. Our north is this side. And if that's north, it means that this side is what? South. So if you have the north and south, what do you do? Next is to predict the field pattern. Okay. It comes like this. And here it comes like that. Then we can have another one. And you can have another one. Okay. Here you can indicate that. And what do we know about magnetic field? It always moves from north to south. So the direction is going to be that. And if that's the case, from north it's coming out. And this side it's entering. So that is that. This is the magnetic field due to a solenoid. And like we said, it is similar to that produced by the bar magnet. And with that, I'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you then. Don't forget to subscribe, to comment, to like, to share. We are simply the best. Bye-bye.